Okay, our next goal now is to teach you how the Arduino can read audio signals, preamplify audio signals, which are generally in the range of plus minus 2 volts maximum, from what I know, up to 2 volts normally. The normal value is 0.7, 1 volt, 1.4, whatever. Okay, these audio signals are alternate current, AC, which means it's plus minus. It's either above 0 or below 0, okay? And let's see now how we can make the Arduino read them. Okay, the Arduino has some analog inputs, A0, A1, A2. I think from our setup here that A4 and A5 are already used for the OLED screen, so we have A0, A1, A2, but no big deal. We actually need up to 2 audio in signals. So what I have done here, okay, let me show you. This here that I'm showing you with a pencil is the live of the audio out of the computer, okay? Through this 1K resistor that I have here, I feed it here, which is the A0 of the Arduino. And this cable here is the ground, goes to the ground of the Arduino. The Arduino analog inputs cannot read negative values, and we should be careful when we feed negative voltages to the Arduino analog inputs. So there could be some ways to get over this, put diodes and stuff like that, but we would lose a lot of signal if we put diodes. So I would leave it as it is, but I have an 1K resistor in series with the signal, and the only purpose of this resistor is all negative values to block them from introducing too much current, so that so internally the Arduino has a very big resistance in series with the analog in, but it doesn't do any harm to add another resistor ourselves. So that's what I did. Then the negative values will be ignored, but this is not a big deal because the analog audio signal has positive and negative values that are nearly equal voltage. So its time, its moment in time, the signal goes from the positive to the negative value. Okay. I don't describe this in English very well, but I'm sure you understand what I want to say. Anyway, let's see now how the Arduino can read the signal from this A0 analog input. So first, we will put here the serial begin. Serial begin command utilizes the serial monitor of the Arduino so that we can see on the screen what kind of signals we get. Okay. Then here, as we had before, Okay, here I will put a variable. It is the audio signal, and this signal is 0. Okay, I will start it as 0. Next, I will use this and this command here initializes the A0 input of the Arduino. Okay, it doesn't do too much, so that's what it is only. Here we have our former program. I will just ignore this now. Okay. Now I will say this. So I put so what this does here, this command, it reads the analog from A0 pin of the Arduino and puts this value to our variable, which is called signal. Let me see. From what I see, this signal is red. Should it be red? Let me change it to audio, because this signal, if it's red, it means it's a command and it means something. So I will make this variable called audio. Anyway, then I will use this command. What is this command now? This command prints the value of audio to the screen so that we can see it. Okay, let's go and see now what kind of values we will get. Okay, serial monitor. So we get zeros. That means, you see, we get here zeros. Getting zeros means the analog input of the Arduino is not reading anything. Okay, now I will try and see why it is not reading anything and come back. So I found what the problem was. A plug that I used to make to connect the Arduino to the line out of the computer had a bad contact. Okay, so I replaced this plug, and here I am again to show you what's going on. So let me upload again this program to Arduino, and now I will open here the serial monitor. There it is, and it will start showing. So if I do no noise, this monitor shows 0, meaning nothing. Maybe some ones or twos are because of a very low sound that it will produce. But if I shout, we see bigger numbers like ah, ah, ah. Can you see them? Anyway, what I will do, I will try to make these numbers more visible by adding a delay here. Okay, I will add a delay of 20 milliseconds, so this way the numbers will scroll slower and you will be able to see them easier. Let me show you. Let's wait. Ah, ooh, okay, the numbers are actually still quick. They're just scrolling too quickly. So another attempt with a higher delay number. Okay. Do you see now that when I don't speak, we have zeros? If I speak, we start getting numbers. If I hit the microphone, let me show you. 92. 168. If I keep on hitting, you can see we get numbers. Okay, I had to stop the recording because there was a phone call. Anyway, as you can see, so the Arduino analog in reads something when there is signal coming from the computer to the pin. Okay, so now the numbers are the numbers don't mean anything. What we can see that we have numbers. Okay, that is the most important thing to know. So let me show you now exactly what the problem is. Okay, I will fire up here my browser. There it is. And let's see. So, okay, let me see. Okay, okay, I have I just fired up a web page here. This is an analog signal. Okay, it's not always the same height, top and bottom, but let's see that it's something like this. Let's open the image here. Okay, so the line, the analog input of the Arduino takes a value at random places during the signal. So this is a constant signal. Okay, it's the same amplitude as you can see here. So it will take a value here, then it will take a value here, but then it might take a value here, then here, then here. It's just random places. So the problem with this, that we don't show the actual amplitude of the signal, but just random points of its amplitude. There is a way to get over this, and I will show you which will be the way. The way will be that we get a series of random inputs, for example, from here to here. Okay, it will be one here, 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 whatever, wherever it will be. But we will take as our value the maximum value of all this, hoping that some of the values they will be around here or around here, which is the amplitude of the signal. Okay, the values at the bottom are ignored, so all the inputs that will receive during this time, they will be 0. Okay, but if we take many values from here and from here, and we just keep the max value of all of them, that means that we have the amplitude of our signal. Okay, now let me show you how we can program this to work. So what we did here is that we just took one reading at a random time point. Let's see now what we are going to do. So we made the loop. Okay, let's see. We made a loop. And so listen what we did here. This is not necessary here. Okay. We made the loop with 50 iterations. What this does is that we read an analog signal 50 times, but each time we keep this max audio variable and we calculate the next max audio variable from the maximum value between the previous max audio and the audio. So at the end we have this max audio variable that is the highest value from all our 50 readings. So this will definitely be a better representation of the amplitude of the signal. Okay, but we also have to declare the variable here, and I will do this now. Okay, now on this output on the serial monitor, we will display the max audio signal. Okay, let's see now. What do the I value is not declared, so we will declare it here. That's how we are. Let's see now. Tools, serial monitor. Let's see now. What did we do wrong? At the beginning of every loop, we have to put the value of max audio to 0 because it's always the highest value from all of the time. So I will have to first put this value to 0 and then do it again. Now let's see what we get now. So now we have some low readings only when I'm not talking. 2, 3, 4, 2, 3, 4 only. But if I talk loudly, you see we have higher readings. So whenever I talk, the readings go higher, and whenever I don't talk, the readings go slower. Let me see if we can represent this to the serial plotter. We have first to close our serial monitor. Let me see. I close it. Tools, serial plotter. Oh. So what do we see here? We have a max audio variable, and this max audio variable is getting higher when the audio signal is high and lower when the audio signal is low. Boo! I think something like that we are trying to accomplish, don't we? So what we have to do now is try and make our OLED screen display this max audio signal, right? Let's try now and do this. I will close this. Okay. I will just comment out this delay. Let's draw a rectangle. Let's draw. Another thing we must see is how high these values go. So they rarely pass 120, so they get values that are about the pixels, the resolution of our OLED screen. So from 0 to 128. Looks nice. I will keep it like that. Now, I will display a rectangle and this rectangle, now I seem to have forgotten how the fill rectangle command works. 10 is how low it is. 30, I don't remember what 30 is. This must be the length of the rectangle. So I will max audio. Okay, I will clear the display. Where? Here. I will clear the display here. I will keep that delay. And I will display the max audio variable. Let's see now what we get in our OLED screen. Hello? Wow. Hello? What about, how about that? So I speak. When I speak, what did we do here? When I speak, the OLED screen shows a display that looks like a VU meter, doesn't it? Let's see if we have constant values from okay, here is our let's fire up a signal generator. A web signal generator. I will use this one. Doesn't look very well. Let me see. Okay. I will take this out because it will drive me crazy. look what happens here. I will decrease the output here. Okay, now as I put this higher, look, the signal is getting higher. I will not talk, not to interfere with the readings, but look how it works. Can you see what happens? Okay, let me stop it. So, if I increase the volume of the signal, this is shown on the OLED screen. So what we have now, we have a representation of the audio signal that's coming out of the computer on the OLED screen, right? So what we actually have is some form of VU meter. That's it for now. I will stop the video. I think we have learned some stuff, and I will continue on another day.